National Fire Protection Association 70, also known as the National Electrical Code, necessitates a service disconnect for all electrical equipment. This includes rooftop air conditioning units. The service disconnect must be positioned within sight of the equipment and be readily accessible. National Electrical Code Article 440.14 dictates that every disconnecting means for motors rated over 600 volts shall be plainly marked with the rated voltage of the motor and the motor nameplate's current rating. National Electrical Code Article 440.15 states that disconnecting means shall be located in sight from the controller location. A primary consequence of this violation is that it presents a significant safety hazard for technicians who are required to work on the unit. The absence of a readily accessible disconnect means that in emergency situations or during routine maintenance, it may not be possible to quickly de-energize the equipment, leading to a risk of electrical shock or other injuries. Another consequence is an increased risk of electrical fires. Without a disconnect, faults or short circuits in the air conditioning unit may not be easily isolated, potentially leading to overheating and ignition of nearby materials. This poses a threat to the building and its occupants. Finally, there is the potential for code enforcement actions by the authority having jurisdiction or OJ. The AHA is responsible for enforcing electrical codes and standards. Failure to comply with these codes can result in fines, penalties, and orders to correct the violation. The recommended action is to inform the facilities manager that the rooftop air conditioning unit constitutes a code violation because of the absence of a service disconnect. Provide written notice to the facilities manager. This notice should clearly outline the specific code violation, referencing National Electrical Code Articles 440.14 and 440.15. as well as detail the corrective action that is required to rectify the situation. Recommend the installation of a service disconnect within sight of the unit. This installation should be performed in accordance with all applicable National Electrical Code requirements to ensure safety and compliance. There are a few additional notes to keep in mind. Firstly, the voltage of the air conditioning unit at 480 volts alternating current is substantially higher than the typical 120 or 240 volts alternating current residential service. Working on equipment with this voltage level necessitates special precautions and must be carried out by a qualified electrician who is trained and experienced in handling high voltage systems. The facilities manager should be aware that the insurance company may mandate a service disconnect for the air conditioning unit as a condition of coverage. Insurance companies often require compliance with electrical codes and standards to minimize the risk of claims arising from electrical hazards. It is of utmost importance to prioritize safety and ensure that all electrical equipment is in compliance with applicable codes and standards. This not only protects technicians and occupants but also mitigates potential liabilities and ensures the reliable operation of the equipment. When addressing the lack of a service disconnect for a rooftop air conditioning unit, several technical aspects need to be considered. These aspects ensure that the installation of the disconnect meets both safety and code compliance standards. Firstly, the disconnect switch must have an amperage rating sufficient for the air conditioning unit. The rating should meet or exceed the unit's full load amps, or FLA, as indicated on its nameplate. This ensures that the disconnect can safely interrupt the current flow under normal operating conditions, as well as during overload or fault conditions. The disconnect switch should have a voltage rating that is equal to or greater than the system voltage, which in this case is 480 volts alternating current. This ensures that the disconnect can effectively interrupt the voltage without risk of arcing or insulation breakdown. The disconnect switch should be of a type suitable for the environmental conditions of the rooftop location. This may include being weather-resistant, corrosion-resistant, and capable of operating within the expected temperature range. National Electrical Manufacturers Association, or NEMA, ratings such as NEMA 3R or NEMA 4X indicate the enclosure's ability to withstand specific environmental factors. The disconnect switch should be installed within sight of the air conditioning unit and readily accessible. This means that the disconnect should be visible from the unit's location without any obstructions, and it should be easily reachable for technicians. The National Electrical Code typically defines in sight from as being visible and not more than 50 feet away. The disconnect switch must be properly grounded to provide a low impedance path for fault currents. This grounding should comply with National Electrical Code Article 250, which specifies the requirements for grounding and bonding electrical systems. Grounding helps to minimize the risk of electric shock and equipment damage. The installation of the disconnect switch must comply with all applicable National Electrical Code requirements, including those related to wiring methods, overcurrent protection, and equipment labeling. It is essential to consult the latest edition of the National Electrical Code and any local amendments to ensure compliance. The disconnect switch should be clearly labeled to indicate its purpose and the equipment it serves. This labeling helps technicians and maintenance personnel quickly identify the disconnect and understand its function. The labeling should be durable and resistant to environmental conditions. Overcurrent protection, such as fuses or circuit breakers, should be provided to protect the disconnect switch in the air conditioning unit from overloads and short circuits. The overcurrent protection should be sized appropriately based on the unit's nameplate data and the requirements of the National Electrical Code Article 430, which covers motor circuits. All wiring connections to the disconnect switch should be made using approved connectors and methods. The wiring should be sized appropriately for the load and should be protected from physical damage. The wiring should also be properly supported and secured to prevent strain on the connections. Before energizing the disconnect switch and the air conditioning unit, all connections should be thoroughly inspected to ensure that they are tight and properly made. The grounding system should also be verified to ensure that it is intact and effective. After the installation is complete, the operation of the disconnect switch should be tested to ensure that it functions properly. This includes verifying that the switch can effectively interrupt the current flow and that it is properly labeled. Documentation of the installation, including wiring diagrams, equipment specifications, and inspection reports, should be maintained for future reference. This documentation can be helpful for troubleshooting and maintenance purposes. Firstly, ensure that the selected disconnect switch is horsepower rated. Given that it is a motor load, it is important that the disconnect is rated to handle the inrush current and lot rush amps, or LRA, of the motor. The horsepower rating ensures that the disconnect can safely start and stop the motor without damage to the contacts. Secondly, if the air conditioning unit has multiple power sources, each power source must have its own disconnect switch. For example, if the unit has separate power feeds for the compressor and the fan motor, each feed must have its own disconnect located within sight of the equipment. This ensures that all power to the unit can be safely disconnected during maintenance or repairs. Thirdly, consider the use of a lockable disconnect switch. A lockable disconnect allows maintenance personnel to lock the switch in the open position, preventing it from being accidentally closed while work is being performed on the equipment. This enhances safety and helps to prevent electrical accidents. Fourthly, when selecting the location for the disconnect switch, consider factors such as accessibility, visibility, and environmental conditions. The disconnect should be located in a place where it is easy to reach and operate, even in adverse weather conditions. It should also be located in a place where it is clearly visible from the air conditioning unit. Fifthly, ensure that the disconnect switch is properly coordinated with the overcurrent protection devices in the circuit. This coordination helps to ensure that the overcurrent protection devices will trip before the disconnect switch is damaged in the event of a fault. Sixthly, consider the use of a disconnect switch with auxiliary contacts. Auxiliary contacts can be used to signal the status of the disconnect switch to a remote monitoring system or to interlock with other equipment. For example, the auxiliary contacts could be used to shut down the air handling unit when the disconnect switch is opened. Seventhly, before installing the disconnect switch, verify that the existing wiring is in good condition and is properly sized for the load. If the wiring is damaged or undersized, it should be replaced before the disconnect is installed. Eighthly, ensure that the disconnect switch is installed in accordance with the manufacturer's instructions and all applicable codes and standards. This includes following the manufacturer's recommendations for mounting, wiring, and grounding. Ninthly, after the disconnect switch is installed, thoroughly tested to ensure that it is functioning properly. This includes verifying that the switch opens and closes smoothly, that the contacts are making good electrical contact, and that the grounding system is intact. 10thly, provide training to maintenance personnel on the proper operation and maintenance of the disconnect switch. This training should cover topics such as how to operate the switch safely, how to inspect it for damage, and how to troubleshoot problems. The specific requirements for disconnect switches can vary depending on the application and the local codes and standards. It is always important to consult with a qualified electrician or electrical engineer to ensure that the disconnect switch is properly selected, installed, and maintained. Remember that the National Electrical Code is updated regularly, typically every 3 years, so it is crucial to stay current with the latest edition and any local amendments to ensure compliance. Also, different jurisdictions may have their own interpretations or additional requirements that must be followed. In summary, the absence of a service disconnect for a rooftop air conditioning unit is a code violation that poses safety risks and can lead to enforcement action. It is essential to address this violation promptly by installing a properly sized and located disconnect switch in accordance with the National Electrical Code and other applicable standards.